Okay, we're continuing on with our Geometry Semester 2 final review. And this is problems, 36 through something. You can have a look in the title for that. Sorry, I didn't look before I started this video. 36, find the volume of the triangular prism. Well, remember that the volume of a prism is the area of the base, that's what the capital B stands for, times the height of the prism, and the height of the prism is the distance between the two bases. Well, notice that this is a triangular prism, so my base is a triangle, and the area of a triangle is 1/2 base times height. And then I'm going to multiply that times the height of the prism. And I'm just going to plug in numbers here. So I have 1/2 times if I look at my triangle, my base and height of the triangle is 12 and 16. I'm going to put those in times the height of my prism, which is the distance between the bases. And then plug in my calculator, and I'm going to get 960 centimeters cubed. Remember that volume is cubed. 37. Circle the 3 methods used to prove that 2 triangles are similar. Remember, similar means that the sides are proportional and the angles are congruent. Well, we learned that if we can prove two sides of one triangle are proportional to 2 corresponding sides of another triangle, and the angle in between them is congruent, that we could say those 2 triangles are congruent using side angle side. We also learned that if we can prove that 1 or 2 angles of one triangle are congruent to 2 angles of another triangle, using the third angle theorem, we know that the third angle is also congruent, then we can say that those 2 triangles are congruent by angle. And then the last way was we said if we can prove that 3 sides of one triangle are in the same proportion as 3 sides of another triangle, so corresponding sides are proportional on all 3 sides of the triangle, then the triangles are congruent by side. 39. Use special right triangle rules. If your short leg is 12, what is the length of the other leg and the hypotenuse of a 45, 90 degree triangle? Well, the first thing, of course, I'm going to ask you to do is to draw a 45, 90 degree triangle. And then it says the short leg. Well, we know on a 45, 90 that both legs have to be the exact same length. And we also know that the hypotenuse is the leg times square root of 2. So my hypotenuse here would be 12 square root of 2. What about a 30, 60, 90 triangle? Well, again, I'm going to have you draw this, and the smallest side of a 30, 60, 90 is across from the smallest angle, which is 30. So we're going to label that 12. With the rules of 30, 60, 90, we know across from 60 is my small leg times square root of 3. So it's going to be 12 square root of 3. And my hypotenuse is always my small leg times 2, which is 2 times 12, which is 24. Number 40. Give the most specific name for each of the following quadrilaterals. Remember, we can't assume anything. We have to go only with the information they've given us. In the first picture, we have all our angles are congruent and all our sides are congruent. Well, that right there is the definition of a square. The next one we know is a trapezoid because we have exactly one set of parallel sides, but notice that the legs of the trapezoid are congruent. That gives us an isosceles trapezoid. On the third figure, the only thing they have given us here is that all 4 sides are congruent. They don't give us any angle information, so we can say that this is a rhombus. On the last shape, they show that we have 2 sets of consecutive congruent sides, which is the definition of a kite. And furthermore, I know this is a kite because the diagonals are perpendicular. 41. Find the volume of the cylinder. Well, remember that the formula for volume of a cylinder is the area of the base times the height, and the height is the distance between the two bases. The base on a cylinder is a circle, so the area of a circle is pi r squared times the height, and then I'm going to multiply it by the height of the cylinder. Okay, and when I do this, I'm just going to plug in numbers from my diagram, and I get that this shape has a volume of 58,835 feet cubed. Volume is cubed. 42. The polygons below are similar. I'm giving you that. So I want you to find the value of x and y. So I'm going to take two sides where I have two corresponding sides where I have numbers in each, like 12 and 4 here. And I'm going to set them up in a ratio and set that equal to y and its corresponding side. And then I'm just going to cross multiply to solve and get y equals 24. I'm going to do the exact same thing with x and 18. Notice here I put the 18 because it goes with my first triangle on top. And I'm going to cross multiply and get that x equals 6. The two triangles below are similar. Give the reason to prove their similarity and then write a similarity statement. Well, remember back a couple of questions ago, the different ways to prove that triangles are similar. And this one literally gives us no side information at all, but we actually do have some information about angles because I know that both of these triangles, the small one and the large one, share angle B. Notice that that small triangle is kind of laying on top of the big one. So they both share angle B, and angle B equals itself. That's the reflexive property. So I've got one angle of each triangle. And then notice that DE and AC are parallel. So as soon as I have parallel sides, I have all of those alternate interior, alternate exterior, corresponding, all of those kind of angles formed when you have a transversal cutting two parallel lines. And because of that, I know that angle A and angle D are congruent because they're corresponding angles. So I can say that, and now I have two angles of one triangle congruent to two angles of another triangle, so I can say those two triangles are similar. And notice that in my similarity statement, I have listed my corresponding sides in the same order. And it is similar by angle, angle. Name the following polyhedra. Remember, a polyhedron is a plane or a three-dimensional solid whose faces are all polygons. Now, the first one is a prism, and we name all polyhedra by their base. Now, the base on this is a 6-sided figure, which is a hexagon. So this would be a hexagonal or hexagonal prism. Now, the next one is a pyramid because we have a base and then we have sides that are triangles that go up to a point. The base on this is a rectangle. It kind of looks like a square, but they don't give us markings, so I can't say that. So it's a rectangular pyramid. The next one is a prism, and the base is a rectangle, so it is a rectangular prism. The fourth one is also a prism, and notice that my bases here are triangles, so this is a triangular prism. And the last one is a pyramid, and 5-sided figure, so this is a pentagonal pyramid. Now, 45, determine if the triangles below are similar. If so, give the reason and the similarity statement. Well, I know that I've got two sets of sides congruent, and I can prove that that third side is congruent. So these two triangles are not similar. They are actually congruent. On 46, solve for A. we learned that 3 parallel lines cut by two transversals have the property that it cuts the transversals proportionately. That means that A is to 20 in the same ratio as 9 is to 15. And then, once you have this proportion, you can just solve and get that A equals 12. All right, that's it for this video. You can go to the next one.